Unit 5. The code is EC8491 Communication Theory Unit 5 Sampling and Quantization. So here the basic is in Unit 5. Just a minute. Okay. So in Unit 5, it consideration of the signal that signal changed to analog to digital. So so far Unit 1, Unit 2, Unit 3 to Unit 4 only concentrated on analog signal, and Unit 5 is it will give the information about digital signal. So before we start the digital, we have to know how to convert analog to digital signal. So for conversion process, that is the information get it from Unit 5. So analog signal is a sine wave nature signal, and digital signal representing zeros and ones, and digital destination. And next, so advantage of digital communication. So once if you want to change analog to digital, so what's the advantage for digital transmission? Because you are changing the signal, and after that you will be transmitting digital signal through to the channel. Then the receiver will be receive the digital, then it convert to a digital to analog. Finally, you will be get the original signal. So why we have to do this? It's an advantage. First, it's a noise immunity and error detection and correction and ease of multiplexing. So noise immunity means so noise is less. Why it is noise is less? Because that analog signal is a nature, noise also nature. So both are nature. So easy to mingle with. That means noise will be interference with the original signal. But it is a digital noise. It is we can't find. Oh, this is some other form. So we can't be interference like that. Noise won't be interference with the digital. So noise immunity is more. The error detection and correction. So easily find out the error because here only transition of zeros and ones. So we can easily error detect and correct. Ease of multiplexing. So we can multiplexing so many signals. The use of multiplexing and integration of analog and digital data. That's a main advantage. Then we have to integrate analog and digital data. Then use of signal regenerators and data integrator and security and use of evaluation of measurements and more suitable for processing. So these are the things as considered as analog to digital transmission advantages. Yeah, if everywhere, any considering any technique, advantages also disadvantages must be faced. So more bandwidth requirements that is needed for digital transmission and need precise time synchronization. So the time period is very precise. So we need precise time synchronization and additional hardware for encoding and decoding. So we need for additional hardware for transmission from transmitting signal. For transmission system, we need there is a two hardware needed. One is encoder from transmitter side and decoder from receiver side. So this additional hardware is needed for encoding, decoding, and integration of analog and digital data. There's a advantage also. They giving the drawback and sudden degradation of QoS quality of the system. So that's a sudden degradation then incompatible with the existing analog facilities. Yeah, so analog facility, the you have to convert analog to digital. Then in the receiver side, you have to convert digital to analog. So that is incompatible. That means you have to add some more extra components or hardware to the transmitter and receiver. The compatibility it will be affect. So incompatible with the existing analog facilities. So these are the disadvantages we are facing in digital communication. So a typical digital communication. So the diagram shown. So how the digital communication will be. So there is analog signal. So there is a transmitter side and receiver side, and waveform encoder or decoder. So transmitter having the component encoder, source encoding, channel encoding, and then interleaving and data packetting, digital modulation, and finally the output sent to wireless channel as a free space. Then the signal receiving digital modulation. So first we see the transmitter side. In analog signal is nothing but a nature signal, but that signal sent to encoder. Then source encoding. Encoding means the original form will be changed to another form for transmitting purpose. Similarly, channel encoding. The hackers might be hacked the signal, that's why they change the form. The hacker should not know what's the original signal. And then interleaving data packeting. So in digital, we send the signal as packet wise. You know, you consider 0 to 7, that is byte. So might be byte wise, we synchronization the data and send it to the channel. So the total signal will be packeted and divide the packet and send through the channel, and finally receive the packet and get the data from the packet. So digital modulation will be modulate the signal, and finally in receiver side we have the digital demodulation. So there will be demodulated signal and channel equalization and de-interleaving and channel decoding and reconstruction low pass filter. Reconstruct the signal, source encoding, and final output will be getting the original signal, same signal. So example, consider my voice as a analog input. Then you are the destination person. So here we are using transmitting digital conversation. That's why it's very clear clarity, and you are receiving the clear clarity. It is output that will be received from receiver side. Okay. Okay. Thank you.